Good morning. Let us start our session. In the previous session, like we were discussing about Kubernetes introduction part. We have understood like the basic architecture of Kubernetes. Let me show you the diagram here. I'll show you the diagram here. You can see this is the Kubernetes architecture that we have seen yesterday. In the previous session, we have seen this architecture and we explained, I have explained each and every component very clearly. What does the Kube API server will do? Or what does the Kube scheduler, the task of controller manager, etcd. These are the components present in the master machine. And we have these components. If you observe these are the components, kubelet, kubeproxy, container engine. These are the components present in the node machine. So we have components in the master machine and we have components in the node machine. And each and every component will have a task. So we understood like what is the task that can be performed by each and every component. Let's move on. Kubernetes. In Kubernetes, we can create various types of objects. As I told you, if we wanted to create any particular object in the Kubernetes, suppose if I want to create a pod, so the main thing that we need to do is we need to write an YAML file. Suppose if I want to create a service object, I need to write an YAML file. If I want to create a secret, yes, with the help of commands, we can do it. With the help of Kubernetes commands, we can create pod, we can create a service object. With the help of Kubernetes commands also, we can do it. But the actual methodology that we follow here is we write an YAML file. We will create pods, deployments, everything with the help of YAML file. So let's understand what are the various types of objects we have in the Kubernetes. Then we will understand like how to create with the help of commands and how can we create with the help of YAML file. So what is a pod? Let's understand what is a pod. Pod is nothing but the smallest object. Pod is the smallest object in the Kubernetes. There are many objects in the Kubernetes, but pod is one smallest object among them. Pod is the smallest object among them. So what does the pod consist of? You know, if a pod is running, if I say a pod is running, inside the pod, the Docker container will be running. If a pod is created and if that pod is up and running, it doesn't mean that inside the pod we have a container running. And remember, there are many objects, or otherwise we can create many objects in the Kubernetes. Among all the objects, pod is the smallest object. If someone asks you what is a pod is the smallest object in the Kubernetes. The smallest object in the Kubernetes. How to create a pod? Either with the help of commands we can create. Otherwise, we will write an YAML file. The better thing is like we need to write an YAML file and we need to create it. And let's understand what are the other objects we have. We have deployment, you see. We have a pod. After pod, we can understand like we have a replica set or replication controller. So what is the use of this replica set or replication controller? This is for replica set or replication controller is for managing multiple replicas. If you want to understand, we have a documentation. Okay, you can go to the documentation of Kubernetes. We have a website called kubernetes.io. Is I'm going to a website called kubernetes.io. So here it is the official website of this Kubernetes. You can go to this website and you can search for you can search for what YAML file for a pod. Okay. I'm asking like, I wanted to create a pod. Okay. I'm just searching for a pod. You see, when I'm searching for a pod, Pod is the smallest object that we can create in the Kubernetes. Let's understand what is the YAML file that we write for the pod and all. For creating a pod, what is the YAML file that we have? Okay, let me show you. So this is the YAML file. This is the YAML file. This is how the YAML file format looks like. We need to write for creating a pod. So let's understand actually. So there are many objects. Okay, I will show you what are the other objects we have. This is how we will write an YAML file for creating a pod. First, let's understand. Let's start with the pod. And let's understand this YAML file format, and then we'll go ahead and discuss the remaining objects. You see here, what are the components that we have inside? We need to understand this particular one. So in this YAML file, if you understand, in this file we have the components like we have 4 top level elements. Not only this YAML, okay? In Kubernetes, if you are going to create any of the object, each and every if you are writing an YAML file for the object, that object will have 4 top level elements. What are the 4 top level elements? Okay, don't look at the YAML. I'll tell you how to understand this YAML file. So there will be 4 top level elements. First one is API version. Very first one is API version. And this is the second one. Second one is what? The top level element of the next top level element will be kind. Kind. What is the meaning? Like you remove this one. Okay. API version, kind, and the next one is metadata. The third top level element is metadata. The fourth one is specification. The fourth one is the specification section. These are the 4 top level elements that any YAML consists of. Not only for the pod YAML. Suppose if you are going to create a pod, or if you are going to create a deployment object, if you are going to create an ingress object in the Kubernetes, service object in the Kubernetes, anything, replica set, whatever it is, okay, replica set or replication controller, or if you want to create HPA, horizontal pod auto scaling, any object in the Kubernetes. If you wanted to create any object in the Kubernetes, definitely we need to write an YAML file, and that YAML file will have these 4 top level elements. That YAML file will have these 4 top level elements like API version, kind, metadata, specification. These are the 4 top level elements that the YAML file consists of. Let's understand what is this API version, kind. Okay. Let's understand what is this API version, kind, metadata, and specification. So to understand that one, yes. See. So usually we will call it as a definition file. So Kubernetes performs container orchestration. I told you Kubernetes is a container orchestration tool. Kubernetes performs container orchestration by using YAML files. What do you mean by an YAML file? YAML file is nothing but the definition file. So whatever the YAML file we are calling now, those YAML files are also called as definition files. So each YAML file, every YAML file or every definition file will have 4 top level elements. These are the 4 top level elements: API version, kind, metadata, specification. We need to understand these 4 top level elements first. Why? Because while writing any YAML, in any YAML, okay, if you are writing YAML for creating any Kubernetes object, these are mandatory things. So let's understand what is API version. So depending on the Kubernetes object you are creating, suppose if you are creating a pod, the API version per pod is different. If you are creating a service object, the API version is different. If you are creating a namespace, it will be different. You see here, for the replica set, okay, for the pod, what is the API version for pod? The API version for pod is V1. The API version for pod is V1. The API version for service object is V1. And you also see, while creating replica set, okay, for pod it is v1, for service it is v1, and for replica set, the API version is apps/v1. The meaning, we cannot say that for all the objects we are creating, for all the Kubernetes objects, the API version we are using is same. What is this API version? API version is nothing but it is a code library, corresponding code library we want to use. There is a corresponding code library we need to use for each and every Kubernetes object. So if you are creating a pod, you need to use the corresponding code library. So there will be some libraries. So while creating a pod, you need to use the code library of V1. While creating the service object, we need to use the code library of V1 only. While creating namespace, we need to use the code library of V1 only. This API version is nothing but API version refers the corresponding code library. So if you remember, like while writing any programming language, okay, if you remember, like while writing C programming or some any programming language, we use header files, hash include stdio.h. So we include the header files. Why we are including? So without writing the entire code over there, without without giving the entire code there, we will just include the code library so that whatever the things that it has to use, it will call from the code library called v1. So whenever we are writing an YAML file, remember, so if you are writing a Kubernetes object, if you are writing an YAML file for creating a pod, definitely the API version will be v1. If you are creating a Kubernetes object called replica set, the API version will be apps/v1. This is the library. There are some libraries. There are some corresponding code libraries. We need to understand. So you don't need to remember all these things. We have Google. You can go through the Google and you can search over there. So you can go through the Google and search like what is the corresponding code library for pod. You don't need to remember them, but you need to understand why we are giving this. Why we are giving this. You can look at the YAML file. Okay, you can look at the YAML file. This is the YAML file that we are giving. So API version colon space. Okay, there is a space mandatory. So it is an YAML file. Since it is an YAML file, we should follow the space indentation and all. Definitely after colon, we have some space and we are giving the value. And YAML file, you know, right? YAML is not a programming language. YAML is a file format. So YAML is not a programming language. YAML is a file format. And you can see here, the whatever the things that we have on the left side, they are the keys. We need to consider them as keys and the right one as values. Okay. So API version for pod is v1. Okay. Hope you understood what is API version. API version, at the API version, we are specifying the corresponding code library. We are giving the code library. So code libraries are not different, are not same for all the objects. They might be different from one object to the another object. But you see here, for all these 4 objects, the API version is same. For these 2 objects, the API version is different. The code library is different for replica set and deployment. For all the remaining things we have. So not only these objects, there are many objects in the Kubernetes, okay, which is not listed out. There are many objects in the Kubernetes which we have not listed out here. No worries, you'll understand, okay. So API version refers to the code library, remember. The code library we are attaching. For pod, we are attaching v1. For service, we are attaching v1. For namespace, it is v1. And for replica set and deployment, you see the code library we are using is app/v1. Hope you are clear in understanding what is API version. Let's move on to this kind. What is kind in the YAML file? As I told you, there are 4 top level elements. One is API version. The other one is kind. Second one is kind. Kind is nothing but the type of Kubernetes object you are creating. So if you are creating a pod, you will mention the name as pod here at the element called kind. So if we are creating a Kubernetes object called deployment, we will simply write deployment here. So based on the Kubernetes object that you are creating, we'll mention the name of the object. Okay, it might be a pod, it might be a replica set, it might be a service object, it might be a deployment object. Now you see, now we are looking at the example YAML file for pod. Okay, I want to look at the example YAML file for deployment. Okay, there is a difference between pod and replica set. Okay, let's go to the replica set. Okay, I'm going to the replica set. Let me show you the YAML file for replica set. You can look at here. What is the API version? The API version for replica set is different. It is app/v1. So the code library that we are attaching for the replica set is app/v1. And you also see here the kind. At kind we are mentioning replica set. Hope you understood the difference. What we are giving, okay, in both the places. You can compare both pod and replica set, okay. You can compare both pod and replica set. You see the pod YAML file. Here we have a pod YAML file. Here we are writing like API version. API version is what? API version is v1, kind is pod. And you see here for replica set, API version is app/v1, kind is replica set. So that's how it differs. So at the kind, we need to specify what kind of object that we are going to create. API version, we by default, it will not change. By default, we should know. Okay, we should ask at least before you write an YAML file, you should know what is the API version. You have a documentation and you can refer this and you can see what is the API version for replica set, what is the API version for deployment. Okay, so like this, we can create objects. Okay, so what is the difference between pod and replica set? Pod means single pod will be created. If I'm writing this YAML file, only single pod will be created with the help of this Docker image. This is the Docker image I told you, right? How we are creating pod. How we are creating pod. Inside pod, what is running? What is running inside the pod? Inside the pod, we have Docker container running. Try to understand. Inside the pod, we have Docker container only running. With the help of this Docker image, see, if I want to create a pod, definitely I should have a Docker image. Without Docker image, we cannot create a pod. Where we are giving the Docker image, you see under specification section. Under specification section, we are providing the image name. What is the image name? Image name is image colon Docker image name. This is the Docker image name. We are providing Docker image name, and this is the name of the container. This is the name of the image, and this is the name of the container. So this is the format that we should use for specification section. Okay, specification, under specification. If you are going to give the container information, you need to give like containers colon. Under the containers, you need to provide the container information. And if you want to specify the ports, yes, you can specify the ports by mentioning like ports. Container port is 80. So this is how the actual format we use for creating. This is the YAML file format we use for creating pod. Hope you understood that what are the top level elements. We have API version, kind, metadata, and specification. What is the meaning? What is the meaning of metadata here? We need to understand what is metadata. Let's understand, okay? We need to understand what is metadata. See here. Kind refers to the Kubernetes object that you want to create. Example, if you are creating a pod, you will give the pod. If you are creating a replica set, you'll give the replica set. If you are creating service, you'll give the service as kind. Metadata is nothing but the additional information about the Kubernetes object. Metadata is the additional information about the Kubernetes object. It might be the name of the Kubernetes object you are creating. Anyhow, we will give the name of the Kubernetes object in the kind section. But additional information, this is mainly for the sake of user only, for understanding, like additional information about the Kubernetes object. If you have any additional information in the Kubernetes object, you can give it in the metadata section. We'll see some examples. What is provided here in the metadata section? You see, metadata, name. So name of the pod, which pod we are creating? I'm going to create a pod called Nginx pod. So this is the metadata section consists of the additional information about the pod. The type of object I'm going to create is pod, and metadata, under metadata, I'll provide some additional information. If any additional information needs to be provided, that will be provided under metadata section. Name is Nginx pod. What kind of, see the pod I'm creating and the name of the pod is Nginx. Okay, I'm creating a pod. Name of the pod is what? Nginx. Nginx pod I'm creating. Under specification section, We'll be providing the container information. Okay, this is how we give the file. This is how we actually provide the information. Like under specification, we'll provide containers. Under containers, you need to provide the image name, container name as Nginx. Ports, if you are going to enable any port, okay, we'll be specifying the container port as like this. And you can also see the YAML file of replica set. So API version is app/v1, kind is replica set. Okay. And the metadata is nothing but like additional information about that replica set. So I'm creating a replica set. The name of the replica set is front-end replica set. So it might be anything. It is not like you have to provide like this only. Okay, it is up to you what the name of the replica set you want to provide, name of the pod you want to provide. But what I'm trying to say is metadata section. The main advantage of having metadata section is like if you want to provide any information, additional information, you can provide the additional information under the metadata section. So if we want to understand more details about this metadata, we'll understand soon. Okay. We'll be understanding why we are using labels. Here you see, here we have an additional field called labels. We'll understand all those things. But you see this is a replica set, right? This is a replica set. Under specification, we are mentioning like replicas, the number of replicas we require. How many number of replicas we require? We require, if I require 2 replicas, I'll give the number as 2. If I require 3 replicas, I'll give the number as 3. So here we can specify the number of replicas that we require. We can provide the number of replicas that we require. If I want 3 replicas, I'll keep 3 here. By the name itself, we can understand it is a replica set. Okay, if we are creating multiple replicas. If it is a pod, only single pod will be created. If it is a replica, multiple replicas will be created. You will understand. Okay, you hope you understood like what are the top level elements we are using in the YAML file. These are the top level elements we are using and the YAML file: API version, kind, metadata, specification. Under specification, it contains the Docker container related information. Specification contains Docker container related information like image name, port mapping, environment variables, all these things. Okay, under specification, we have the Docker container related information. So usually, okay, we need to see the practicals. Okay, we can see the practicals. But let's discuss the theory part for today. Then we will start the practicals from the next session. Okay. So how can we create? Suppose if I have an YAML file. Okay, I have an YAML file. This is the YAML file I'm having. Let's see. This is the YAML file I'm having. Pod YAML I'm having. How to create this? This is the YAML file I'm having. How to create the pod? To create the pod, we need to run Kubernetes commands. We need to run some Kubernetes commands. What is the Kubernetes command that we need to run? You can see here, kubectl create -f pod definition.yaml. We can create. So we need to save the YAML file. We need to save that YAML file with some name like pod definition, pod.yaml, pod2.yaml, pod3.yaml. Anything, it is up to you. You can save your pod YAML with any of the name. And if you want to create a pod, you need to run this command kubectl create -f. Kubectl create -f pod definition.yaml. You need to create a pod with the help of this command so that the pod will be created. This is the command we use to run kubectl create -f pod definition1.yaml. So this name can be anything. You can give any name. You need to save the YAML file with some name like pod1.yaml, pod2.yaml. kubectl create. All the Kubernetes commands will start with kubectl. All the Kubernetes commands will start with kubectl. All the Docker commands starts with Docker. All the Maven commands will start with MVN package, MVN clean, MVN install. All the Kubernetes commands will start with kubectl. If I run this command, kubectl create -f pod.yaml, pod1.yaml something, pod will get created. Yes, pod gets created. So with the help of YAML file, okay, we are writing an YAML file and we are running this command so that the pod is getting created. And if you want to see the list of pods, If you want to see the list of pods, how many pods got created, whether the pod is up and running or not, to see the list of pods, we will use a command called kubectl get pods. Very simple command. We'll use a command called kubectl get pods to see whether the pod is up and running or how many pods that have created. Kubectl get pods. And if you want to know the more information about the pods, okay, if you want to see the more information about the pod, and usually where the pods will run, you need to understand where the pod is going to run. I told you actually where the pod is going to run and all. You need to understand this very, very clearly. We have a Kubernetes cluster. I told you already. Inside the Kubernetes cluster, we have a master machine, which we had a discussion in the previous sessions. This is a master and we are having some nodes. Okay, assume that we are having some nodes. Consider this is a 4-node cluster. Consider this is a 4-node cluster, meaning this cluster is having 4 nodes and 1 master machine. This is master machine. There will be master machine. There will be a master machine, definitely. Even in the cloud also, there will be a master machine, but we cannot see the master machine. All the master machine activities will be handled by the cloud. We will not see the master machine. But in the on-premises, if we want to install Kubernetes, definitely we will be we'll be configuring master machine and then we'll be configuring the node machines. Okay, so now here we have 4 nodes, right? So where our pods will be running? Inside the cluster, we have a node. This is node 1, okay? If you understand, this is node 1. This is node 2. Okay, these are the nodes. This is node 2, this is node 3, and this is node 4. 4 nodes I'm having. So if you run a command kubectl create -f, so the pod will get created in any of the node. Usually the pod gets created in any of the node. If we have 4 nodes, the pod is going to be created randomly in any of the node. Consider here in the node 1, the pod is created, the pod is running. And if you want to increase the number of replicas, yes, you can increase the replicas. Try to understand, pod is getting created inside the node. Where the pod will run inside the node. I don't know if I ran the command kubectl create -f pod.yaml, pod gets created. If I have 4 nodes, and if I would like to know in which node the pod is created, in which node, I have 4 nodes. I would like to know whether in node 2 the pod is created or node 3 or node 4, in which node the pod is created. I would like to know. If I would like to know, we can use a command called kubectl get pods -o wide output. -o wide stands for wide output. If you want to see okay, if you want to see in which node your pod is running, definitely you can give a command called kubectl get pods -o wide output. Kubectl get pods -o wide output. Okay. And this is the command we use for deleting the YAML file. So usually if we don't want, okay, if you wanted to delete, for deleting the YAML file and all, we can use this command kubectl delete -f pod definition.yaml. So how we are creating in the same way, kubectl create pod.yaml. In the same way, kubectl delete pod.yaml. So this is how we can delete the YAML file. So these are the basic commands that usually we use: kubectl get pods, kubectl get nodes. We can also see how we are giving kubectl get pods in the same way. If I want to see the information about the nodes, how many nodes are there and all, we can give kubectl get nodes. Kubectl get nodes is the command which will display the list of nodes. Kubectl get pods will give you the list of pods. Kubectl get nodes will give you the list of nodes. And at the same time, you can also run a command called kubectl get nodes -o wide. You can also use the same command for nodes also to see the more information about the nodes. What is the IP address of the node? Okay, so more details about the nodes and all. If you want to see more details about the nodes and all, you can run a command called kubectl get nodes -o wide. -o wide stands for wide output. So to delete the YAML, this is the command we use. So for now, we need to understand, like, this is an YAML file. So if I'm writing an YAML file for a pod, only one single pod will get created. Only single pod will get created. And let me show you. If you see here, the next object, okay? The next object that we need to understand is replication controller. we have an object called pod. So we have another object called replication controller. Try to understand the difference between a pod and replication controller. Replication controller is mainly for handling multiple replicas of a specific pod. See here, everywhere everywhere we will be giving only single Docker image. Here in the pod.ml, the Docker image is Nginx only. The Docker image is Nginx only. Okay, if you want to create, if you want to create a pod, definitely we will write an YAML file and we will run the YAML file. I have shown you how to run the YAML file. kubectl create-f pod.yaml. That is the command we use to run the YAML file so that the pod will be created. Single pod only will get created here. Why? Because we are not giving any replicas. We are not mentioning any replicas. We don't have any option here to increase the replicas. In the pod YAML, we don't have any option. So pod is an object. It is the smallest object. We don't have much advantages with this. We don't have much advantages with the pod object, but you see here, if you want more replicas, you can go for an object called replication controller. If I use pod YAML, I cannot increase to multiple replicas. I cannot go ahead and increase multiple replicas with the pod YAML. So that's the reason why I'm going for a replication controller. In the replication controller, I see here I am having a section called replicas. Under specification, I can give replicas colon some number. So meaning I can go ahead and create multiple replicas with this object. Hope you are able to understand. I can go ahead and create multiple replicas with the replication controller. It is a high-level object. Replication control is a high-level object which is used for handling multiple replicas. Which is used for handling multiple replicas of the pod. Why we need multiple replicas? You must have an understanding why we need multiple replicas. Yesterday, in the previous session also, we were discussing why we need multiple replicas for the load balancing. To perform load balancing, if I get more requests, if I'm getting more load, how the entire load can be balanced without multiple replicas? Single pod cannot handle the entire load. Single pod cannot handle the entire load. That's the reason why we are going for the other objects. If you want only single pod, if single pod is enough, then directly we can go for a pod.yaml. So if you want more replicas, if we require more replicas, definitely we will go for replication controller. So this is not only the object, okay? Replication controller is not only the object we have for increasing the number of replicas. We have many other objects, but try to understand this is one object where we can increase the number of replicas. And try to see the YAML file, okay? You can see the YAML file for replication controller I have shown you, okay? Let me show you the replication controller YAML file. So what is there here? What is the difference you can see here? Under specification section, we have a component called replicas. We have a field called replicas. Under replicas, clearly we are specifying that 3 replicas we require, 4 replicas we require, so that 4 pods will be created. If I give 3 replicas colon 3 pods will be created with the same Docker image. Okay, same pod, similar pods, 3 similar pods will be created and they will be running. Why we need replicas? To handle the load. One pod cannot handle the entire load. That's the reason why we increase the replicas. If one pod can able to handle 100 requests. If I have 3 pods, all the 3 pods can handle 300 requests. Load balancing. Okay. For load balancing, we are going for the number of replicas. Okay. So this is one more object in the Kubernetes. If you want more replicas, you can go for replication controller. Okay. If you want more replicas, you can go for replication controller. Like that, we have other objects. We have some other objects also. Let me show you. We have the other objects also. We have a replica set, okay? We have replica set. We have replication controller, replica set. There is a difference between replication controller and replica set. Hope you understood. We have components like, so we were discussing about the components. So what are the things you can see now? we have pod. Pod is one object in the Kubernetes, and we have a component called replication controller. We have a component called, we have an object called replication controller, and we also have replica set, and we also have deployment object in the Kubernetes. Deployment object. We have service object. We have ingress object. We have HPA. Like this, there are many objects in the Kubernetes. There are many objects in the Kubernetes. So let's understand. Okay, let's understand each and every one. Let's understand one by one very clearly how to create a pod, how to create application controller, how we are going to create replica set, all these things. How, what is the difference between each and every one? What is the difference between pod and replication controller? And what is the difference between replication controller and replica set? So all these things, what is the difference between deployment object and replicas? All these things we'll be discussing. What is the purpose of service object? What is the use of ingress object? What is the use of HPA? So all these things we'll be discussing in the further discussions. Okay. So how we are going to practice? Okay. How we are going to practice Kubernetes is, so we are going to practice. Actually, we can practice in some cloud. We can go to the Google Cloud, or we can go to the AWS and we can practice Kubernetes. Maybe for free trial, they are not allowing us to enable to practice the Kubernetes. So that's the reason why you can install Docker desktop in your machine. Okay. So please try to install Docker desktop in your machine. So once you install Docker desktop, let me show you. Once you install Docker desktop, so how to install Docker desktop? I'll show you. Like you need to go to the Google and search like Docker desktop download. Search with Docker desktop download and click on Docker desktop. So you will see some versions here. Okay, you will see some versions here. Click on Docker download Docker desktop. So our version is like Windows. Okay, if our version is Windows, we'll download this one. Download for Windows ARM64. We'll download this version, download for Windows ARM64. So once it is downloaded, okay, once it is downloaded, you can install it. An exe file will be downloaded. You can install it. Once it is installed, you can see here, this is how the shortcut will be created on your machine. The shortcut will be created on your machine. Okay, just open the shortcut. Just double click on the Docker desktop so that the Docker desktop will be opened. So it is already in the open state. Maybe I have installed it. Some issues are there. Okay, anyhow, I'll try to resolve them. So what you need to do is you need to download Docker desktop into your local machine and you need to install Docker desktop. Once Docker desktop is installed, so we will practice. We will try to practice. See here, this is how actually the Docker desktop will be opened. And you can go to the settings option. Okay. You see, once the Docker desktop is installed and you open the Docker desktop, you can open the interface of the Docker desktop. You can just double click on the Docker desktop and you can open a window like this. The window will be opened like this. And so here you have an option called Kubernetes. Can you see on the left navigation, you will see one thing called Kubernetes. Just click on the Kubernetes. By default, the Kubernetes is disabled. Okay. By default, the Kubernetes is disabled. What you need to do is you just need to enable the Kubernetes. That's it. So once you download and install Docker desktop, please double click on the Docker desktop and open it. And go to the settings. On the left navigation, you will see Kubernetes. Just click on Kubernetes, enable the Kubernetes, and just click on apply. So now I have already enabled it. So what you need to do is you need to enable and apply. So click on enable and your apply, here this apply will get highlighted, apply button will be highlighted, and just click on apply so that the Docker desktop will be installed in your machine. The Kubernetes, we can use Kubernetes in the Docker desktop. So what is the cluster that's created? So here you can see here, we are going to work with a single node cluster. Start a Kubernetes single node cluster. So we'll be getting a single node cluster. We have a Kubernetes option here. We will work with a single node cluster, and we will see how to connect with the Kubernetes, how to run our commands. Okay, all these things we will understand. So this is what we need to discuss for today. So what I'm asking you is like you can go ahead and install Docker Desktop. So once you install Docker Desktop, then we have an option here to see like Kubernetes. Okay, we can go and see like Kubernetes option. We can enable Kubernetes. We can apply it so that single node cluster will be enabled. And I'll show you like how can we connect to the Kubernetes cluster and how can we run the Docker commands, all these things. Okay, thank you. I'll stop this for today. Let's meet tomorrow. Let's understand more on Kubernetes.